Welcome to The Explainer. Today, we're going to tear into the first chapter of a really influential book, John Ousterhout's A Philosophy of Software Design. And right from the get-go, it's all about one thing, waging war on complexity, the #1 enemy of every single developer out there.
So the book starts with just this really powerful idea. Think about it. When you're an architect or a sculptor, you're limited by, physics, gravity, materials. But as programmers, we're not bound by any of that. We can literally create whole worlds from scratch, and the only real limit is our own imagination. It's creation in its purest form.
But, with great power comes, well, a pretty big catch. This incredible creative freedom has one huge single limitation that hangs over everything we try to build.
And that's it, right there. The thing holding us back isn't how fast our computers are or how much memory we have. Nope. The ultimate bottleneck is our own brain. As the system grows, as we add more and more features, it just gets more complicated, and it becomes almost impossible to hold all those moving parts in your head at once.
And this leads us straight to the central villain of this whole book, the one thing this entire philosophy is designed to fight: complexity.
Okay, now this is really interesting. Check out Ousterhout's definition. Complexity isn't about how many features a system has or how big it is. You could have a massive system that's actually pretty simple to work on. No, complexity is all about how it feels for a developer to modify it. So, if making a seemingly simple change is a huge headache, that's complexity.
So, what does that feel like? How do you know when you're wrestling with complexity? Well, it's not just a vague feeling of, man, this is hard. It actually shows up in a few very distinct, very frustrating ways.
Yeah, these are the big red flags. First, you've got change amplification. That's where you make one tiny little tweak, and suddenly you have to change code in 10, 20, 50 different places. Then there's high cognitive load. This is when you have to basically become a walking encyclopedia of the entire system just to make one change without breaking everything. And then, the most dangerous one of all, unknown unknowns. This is when you don't even know what you don't know. You have no idea what code you might need to touch or what information you're missing.
And this image, this just nails that first symptom perfectly. Look at Design A. To change the website's background color from red, the poor developer has to hunt down and edit every single page. It's a massive, error-prone nightmare. But in Design B, the color is defined in just one central spot. You make one change, and boom, the whole site is updated. That's what a simple, elegant design looks like. That's how you fight complexity.
And the stakes here are really, really high. When complexity spins out of control, development just grinds to a halt. Every change you make introduces a wave of new bugs, and the cost to just maintain the system goes through the roof. Honestly, this is what kills projects.
Okay, so here's the crucial part. We're not helpless in all this. We can fight back, and we have to. The book lays out two main strategies for waging this war on complexity.
So strategy number 1 is to just eliminate it. Get rid of it entirely. You do this by making your code simpler, more obvious, maybe by getting rid of a bunch of weird special cases. The second strategy, and this is the one you'll probably use more often, is to encapsulate it. Basically, you hide the complexity. You tuck it away inside well-defined modules, like classes, so that a programmer can work on one piece of the system without having to understand the whole shebang.
All right, let's see how this all builds up into a really fundamental shift in mindset. This is what separates truly great software design from code that just kind of works. Now, this idea right here, this is an absolute game changer. Ousterhout argues that your main job as a developer isn't just writing code that works right now. No, your most important job is to create a design that makes it easy for the next developer to build on it. And hey, that next developer might be you in 6 months. It's the long-term health of the system that matters most. And this leads to two totally different ways of programming. On one hand, you have the tactical programmer. Their goal is just to get something working as fast as humanly possible, even if it adds a little mess. They're always saying, I'll clean it up later. But then you have the strategic programmer. Their main goal is to produce a great design that also happens to work. They're thinking, you know what, a little extra investment right now is going to save us a ton of time down the road.
And this first mindset gets a great name, the tactical tornado. This is that developer, we've all known one, who seems like a total hero to management because they are just pumping out features like crazy. But to the rest of the team, the people who have to actually live in that codebase, they just leave behind this wake of destruction and complexity that slows everybody else down.
This graph shows that trade-off just perfectly. Look at the dotted line, the tactical approach. It shoots up at the beginning, right? It looks like it's making faster progress. But as all that messy complexity builds up, the line just flattens out. Progress slows to a crawl. Meanwhile, that solid strategic line starts out a bit slower. That's the investment in good design. But it quickly overtakes the tactical approach, and in the long run, leads to way more progress.
And this is exactly what we're talking about when we say technical debt. Every single one of those tactical shortcuts, every time you say, I'll fix it later, you're basically taking out a loan against future productivity. And just like a real loan, it's not just the principal you have to worry about. You're going to be paying interest on that messy code in the form of slower development and more bugs for the entire life of the project.
So the chapter leaves us with this final thought, a question for all of us to really think about in our own work. Every decision we make, every single line of code we write is either an investment in that long-term simplicity or it's another loan we're taking out from the future. The question is, which path are you on?